Hey everyone, in this video we will discuss the question from CSIR NET Mathematics 7 June 2023 from the topic differential equation. So this is a question from system of differential equation. Let's see. The question says that if xt is the solution of the following initial value problem. Okay, so before I read the question, you read the question, pause and read the question, and just think about xt, how xt looks like. Okay, later I will tell you, but you just think how xt can be looks like because this is a system of differential equation. Of why this is a system, let me tell you. So it is saying that x dot equal to ax, right? And x at the point 0 is given x0. And what is this x dot equal to ax? What is your a? A is a matrix. So what types of matrix it is? It is a 2 by 2 matrix, right? This matrix 5 4 1 2. Now they are saying that which of the following statement is true. So they are saying about the nature of this. So xt is bounded. This will tend to 0 or infinity or where. Okay. So let's see how we can solve this question. Now see, why I am saying first of all that this is a system of differential equation. If you write this x dot equal to ax, okay, then you will get the form like this. So suppose this is your x dot. So I am writing just for convenient x dot t equal to dx dt and dy dt. Okay, and your x dot is a into x. So your a was 5412 and x I am writing as xy. Okay, so if you write this, then what it will be given? It will give 5x plus 4y, and in the next column it will give x plus 2y, right? So that is this two. That means you are getting two equation. One is dx dt equal to 5x plus 4y, and another one is dy dt equal to x plus 2y. So isn't it a system of equation? So since this is a differential equation, that's why we are calling it a system of differential equation. And also the equation is linear, right? X is linear, y is linear, so we will call this equation of system of linear differential equation. Also homogeneous in the sense, since we are writing at x dot t equal to a into x, so in somewhere you will get a equation looks like x dot equal to ax plus some function, some another function. Okay, so then that will not be homogeneous, that will be non-homogeneous linear differential equation. Okay, but this is not the case here. Here your case is for linear differential equation. Now let's see. So this is your differential equation. Okay, now system of differential equation. Now we have to think about the solution of this. So how we can solve? The solution is given by, suppose the system is this x dot equal to ax, then this a is called the coefficient matrix. Okay, so if I am saying this as coefficient matrix, then we have to see the eigenvalue of this and the eigenvector of this, and from there you will get the solution. I have written this here, that suppose lambda 1 and lambda 2 eigenvalues of this a, and say v1 and v2 are their corresponding eigenvector. Okay, so v1 is the eigenvector for lambda 1 and v2 is the eigenvector for lambda 2. So if these are their corresponding eigenvector, then their solution will looks like this: c1 e to the power lambda 1 t into v1 plus c2 into e to the power lambda 2 v2. Okay, now this is the solution. Now let's see, if this is the case, then for our question what will be it is. So this is the matrix, right? 5412. So clearly you can see that row wise this is 5 plus 1 6, this is 4 plus 2 6. So since this column wise their sum is same, that is 5 plus 1 is 6, 4 plus 2 is 6, that means 6 is an eigenvalue of this matrix. And also since the trace of this matrix is 5 plus 2 is 7, right? So since 6 is an eigenvalue, so the rest of the eigenvalue must be 1. Okay, 6 plus 1 is 7, so the trace you have to manage, right? So trace is 7, that means the other eigenvalue should be 7 minus 6, right? So that is 1, because 6 is an eigenvalue already. 5 plus 1 is 6, 4 plus 2 is 6, so 6 must be an eigenvalue. So that means 6 and 1 is the eigenvalue of this. So it's now how the solution will look like. Then the solution will look like this, right? So lambda 1 is 6 and lambda 2 is 1. I haven't computed the v1 and v2 because it is a MCQ question, so that's why I haven't compute this up to the time that I don't know whether it is needed or not. Okay, so for now I have 6 and 1 is the eigenvalue and the solution is looks like this. Now the question says that is xt bounded solution. So can you tell me from there that xt is bounded or not? As t tends to infinity, e to the power t is tending to infinity, right? As t tends to infinity, e to the power t is tending to infinity. So if e to the power t is tending to infinity, then xt is bounded? No. That means this option is wrong. Now, the second option says e to the power minus 16 to mod of xt. Is it tends to 0? Look, if you see e to the power minus 16 to mod of xt, what will be it is? If e to the power minus 60, then e to the power minus 16 to e to the power 60 is 1, right? So it will be left out with c1 into v1 plus c2 into e to the power t into e to the power minus 60. That means e to the power minus 50 into v2. So this e to the power minus 50 will tend to 0 as t tends to infinity, right? But these things, C1, V1, whether it is 0 or not, we don't know. So this option is also wrong. So this is also a wrong option. Now option 3 says e to the power minus t into mod of xt. Is it tends to infinity? The fourth option says e to the power minus 10t into mod of xt. Is it tends to 0? Let's see. E to the power minus 10t into mod of xt. It will looks like this. C1 e to the power minus 16 to e to the power minus 10t is e to the power minus 40, right, into v1 plus c2 into e to the power minus 90 into v2. So that means as t tends to infinity, this e to the power minus 90 is also tending to 0 and this e to the power minus 40 is also tending to 0. That means the whole thing is tending to 0, right? So the option also says that e to the power minus 10t into mod of xt is tending to 0. That means this option is right. Okay. So now I have tell you the technique to discuss the option. Okay. Now you check the option 3 and comment me whether it is a right option or wrong option. Okay. Since it is MCQ, if you put option 4, then you will get mark. But you tell me, you think and tell me that option 3 whether it is true or wrong. Okay, so for this, thank you.